Okay, let's get started. Welcome to the latest live stream for 10x. Right. Today I thought I would talk about something I'm working on currently, which is the text encoding and BOM headers and things like that. Just because it was what I was doing late last night, fixing the last minute bug. Oh, but first, before I do that, I was going to show you some of the latest changes. Let's see if I can get them to work. Something I've literally just been working on, which is the multi-cursor editing. Let's see if it works. Right screen. Okay, so with multi-cursor, as you obviously, I'm sure you know, you can set multiple cursors like so, move them around, and write text. Okay. But one of the weird things is when you get to the end of the line, they kind of wrap around and then do slightly odd things, and you kind of think, well, where actually am I? And so it can be a little bit confusing. And the other way to use multi-cursors is to use what I call rectangular select, which using the Alt key, you can select a square or rectangular region. It creates a selection, a new cursor for every line, which is quite nice. You can delete stuff like that. But it was getting a bit confusing when you move the cursors around. What I've made it do now is, as you move the cursors around, they stay. So as you can see, I can move them anywhere on the screen, and it's a lot more easy to use. The other thing I've literally just added is if I select a region like that, copy it, clear the multi-cursors, and then paste it in, then it pastes the rectangular region in here, rather than sort of copying a region there and then pasting it in, and it pastes it there. It actually detects that you're doing one of these, and then you can place the cursor anywhere you like, and just paste it in. And I find, I mean, I'm not a big user of multi-cursor, to be honest. I've never really used it, but the only thing I do use it for is this square region select, copy, paste, especially when I'm doing columns of stuff, you know, mapping enums to strings or whatever, things like that, and it's really useful. So hopefully you'll find that a little bit easier to use with multi-cursor. As I said, I don't use multi-cursor much, so I'm kind of relying on people to let me know when it's not working as you'd expect, just to make it work exactly as we all want it to work. So a question: hi, I've been following progress of 10x very closely. Sorry, I haven't been following progress of 10x very closely, but I'm excited for a Visual Studio replacement. Do you plan on adding any Vim style keyboard key binding support? Yeah, I've had that question a few times. Yeah, I'm sure I will at some point. It's not high on my list right now, I must admit. It might be something people could emulate with the Python scripts. It's worth looking into. You can already bind things to keys in the Python scripts, and yeah, it may be something that people can do themselves. But yeah, I'll definitely be adding official support at some point. But I've never been a Vim user, so it's not something I'm totally familiar with. So I'd have to look up all the details on how it all works. But I'm sure it's not that complicated. Okay, so that brief aside, I'm going to go back to NX, what I was going to be talking about. Make the font a bit bigger. Okay, I'm running in debug here, so it's going to be a little bit slower than usual. Text encodings. So, just got someone saying becoming a Vim user is a one-way deal. You can never go back. Yeah, I've heard that a lot. I've never been sucked into Vim, unfortunately, but yeah, I know people love it, and it's very powerful editor. So, yeah. Right, so encoding. I somehow managed to get through my entire programming career without really understanding text encodings. You know, I know about localization in games and things where you have to use white chars instead of chars and you get special characters. And I vaguely knew UTF-8, but I didn't really know what it meant. So yeah, it was a bit embarrassing just not knowing the basics of it. So obviously, writing a text editor, that's one thing I need to know, because at the very least it has to deal with text encodings. So I did some research and taught myself. So I thought I'd give you a very quick crash course on text encodings and character sets and all that shenanigans. So I've added, when I was up late last night doing, I've added an encoding thing to the editor, so the edit menu. So you can now see whether the file is in UTF-8, UTF-16, big endian, little endian, or ANSI. And you can also see whether it's got a BOM or not, which I'll explain in a bit if you're not sure what a BOM header is. And you can change these. So if you select them, as you see, I'm changing between them now, and I can toggle the BOM header on and off here. And when I save the file, it will save it out in that encoding. So it's very powerful to be able to see what the text file is and to be able to change it if you need to. Right, so let's talk about Unicode first. I mean, even Unicode, there are a lot of misunderstandings about what this is. Before I start, I should say that a lot of this text encoding stuff, a lot of people use the wrong terminology and it's just become so ingrained that everyone uses it now, and it's confusing because it's wrong, a lot of it, but it's just what everyone uses. But I'm going to try and, as much as possible, as much as I can remember, to try and give you the right way of thinking about it, because it kind of makes sense. So Unicode is a character mapping or set. It literally just maps numbers to characters, or glyphs, or whatever you want to call them. Now, wchars, ychars in C++, obviously, as we all know, 2 bytes. And a lot of people refer to this as Unicode using wchars. Now, it's not. Unicode is a character mapping set, and from my notes here, it's got 200,000 odd code points in Unicode, which is obviously a lot more than 2-byte mapping, which you can get 65,000 obviously. So as I'll come on to make it more clear, hopefully, wchar is not a code mapping, it's not a character set, it's literally just I'm going to store this code point in 2 bytes. And you get a subset of the whole Unicode character mapping. And 65,000 is quite a lot. You get a lot for it, you get a lot of different languages, even stuff like kanji and Japanese, and a limited character set, but usually wchars are enough to store pretty much everything. So I should come on to what a code point is. A code point literally just is saying it's a mapping number to a character. That's all it is. It's just a code point. Code points can be anything you like, but ideally, if you want to cover all characters in the entire world, you need to use 4 bytes, which is more than even Unicode. So there are hundreds of thousands of characters you can store in 4 bytes. You can store everything. But as I was saying, we don't always need that many characters in reality. I mean, in reality, obviously we use ASCII a lot for most things, at least in the English language. Oops. So they're for characters 0 to 127, and they're A, B, C, D, etc., etc. Just the usual characters, nothing that fancy. So they're in 1 byte in range 0 to 127. I'll show you why we're not using the top bit shortly. So in a way, let's just start on next. Okay, let's move on to UTF-8. So this is a text encoding. Now, the thing to realize is text encoding is very different than a character mapping or a character set. So as I was saying before, a character set maps numbers to characters. Simple. This number is this character. A text encoding, think of more as a compression scheme or a save format or something like that. So just quickly to say what UTF is, for those of you who don't know, I'm sure most of you do, but it's a variable length encoding. So each character, I mean, character is not the technical term, it's just the one I've always used and I can't stop using, but you know what I mean by character, you know, one of these. So a character, a code point, technically, can be mapped, like I said, to 4 bytes to cover every single one in the whole world. Almost said the whole universe, but that's probably not true. So a code point can be mapped to 4 bytes, it can be mapped to 2 bytes as in a WString, it can be mapped to 1 byte in case of ASCII. So a code point can be represented by any number of bytes. Now, a text encoding is a variable length, so a code point could be mapped to 1 byte, which is typically, if it's just in one of these ranges, it would just be 1 byte. If it's outside of that range, it could be mapped to 2 bytes. So the first byte would be saying this, the first bit of the first byte would be saying this code point or character is going to be mapped by 2 bytes, or 3 or 4 bytes. So you can have up to 4 bytes. So this variable length encoding means you can encode an awful lot of these code points. Well, pretty much all of them, not quite all of them, but most of them. And in the normal case, where you're just using ASCII, you just have 1 byte per character. If you then start having some European, such as the umlauts or some special characters, then you might get into 2 bytes. Then if you go to things like kanji or Japanese, you might get to 3 bytes, or Russian, 3 bytes or 4 bytes or whatever. So all these other different characters will increase the number of bytes you're using to store that code point or character. And that's basically what it is. I'm not going to go into exactly how it works, but it's just basic. I mean, you can kind of guess. It's just like a compression scheme, basically. Now, the way I think about these things is so I think of text encodings as how I save the text file on disk. And in memory, I use code points. Now, it doesn't actually have to be that way, and C++ is bringing in UTF-8 for in-memory strings as well. But I'm not sure that's a great idea. Not that big fan of that. But there's no reason you can't have encodings in memory as well. This is just the way I think about things. Encodings is how I encode it on disk. And in memory, it just expands to code points. And these code points, like I said before, code point could be 4 bytes, could be 2 bytes, could be 1 byte. It doesn't really matter. So moving on. So yeah, why don't we use 4-byte code points everywhere? I mean, it would be a hell of a lot simpler. We wouldn't have to have any encodings at all. We could just store on disk every character is 4 bytes, and in memory every character is 4 bytes. And we wouldn't need any of this weird UTF-8 encoding or variable length encoding or anything. Everything would just map to what it is. It'd be really simple. And in a way, if we were starting from scratch now, it's probably the way we would do it, because memory is not so vital. But it is nice to have strings in memory in 1 or 2 bytes, so that when we look at the file, let's go to just some random file and look at it in binary. Quick way to look at things in binary is I actually use Visual Studio. So I've never found a good binary editor. Maybe I'll write one day. And you just change it to .bin and then open it in Visual Studio. So as you can see, this file is actually ASCII, so it's using 1 byte per character. It's also UTF-8, which I'll explain in a minute. But as you can see, 1 byte going to each character is really nice. You can see it in the memory window, and when you're debugging, you can see it in a file. And imagine if each of these characters was 4 bytes, it'd just be a lot more difficult to work with. So it saves memory, not storing everything as a code point, and it just makes it much easier to work with for us programmers and us human beings who want to see things in a simple, readable way. So we talked about UTF-8. I'm not going to go into details, like I said, on that, I don't think. It's not actually that interesting. You can probably guess how it works. Obviously, we've got UTF-16 as well. Obviously, this is just like UTF-8, but each I don't know what to call it. It's not byte or character, or each value is twice as big, obviously, so it's using 2 bytes. So each code point will be mapped to 2 bytes, or 4 bytes, or 6 bytes, or 8 bytes, instead of 1, 2, 3, or 4. And it does allow you to have a greater number of characters than UTF-8. But UTF-8 is pretty much good enough for anything. You can have hundreds of thousands of different characters represented in it. And, question: how are the next line characters stored? In the hex editor doesn't show anything at the end of and anything at next lines. Not quite sure what you mean. Maybe you can clarify that. But if we're looking at this, you will see the new line characters here, 0D and 0A, which map to /r and /n, or the other way around. So yeah, they are, and some only have 0A and not 0D. I've got that the right way around. But yeah, they are there. So yeah, it's hard to see sometimes. I'll probably make this a bit bigger. I can't zoom in. Visual Studio, let me down. I have to write me in text editor. Anyway, right. So where did I get to? UTF-16, yeah, you can guess how it works, just twice as big as UTF-8. Allows you to store more stuff. Now, most of the world uses UTF-8 for everything, pretty much. I mean, if you look at the stats on websites and what encodings they use, it's pretty much all UTF-8 because it's very efficient, it's very small for most text, and it's very powerful. You can pretty much show any characters you need to in most languages. So UTF-8 is enough, and it's pretty much comes the standard. The other nice thing about UTF-8 is if your file, like the one we just showed, there are no special characters in here because I'm English and I don't use special characters much. So it is actually ASCII. It's only using characters in range 0 to 127, as you can see here. Even the new lines we just talked about are in that range as well. So you could say that's an ASCII file, but we could also say it's a UTF-8 file because ASCII is a subset of UTF-8. Like I said before, because it's a variable length encoding, if you're only using the characters in that range, each code point will just be 1 byte. So ASCII is a subset of UTF-8, which does simplify a lot of things. Well, actually, because I'll come on to next, the BOM. Byte order mark, I think that's what it stands for. BOM header, let's call it. So let's see if we can show what I mean. So this is just a quick test. I've used the E with the hat on it as a special character that's outside of the range, oops. So it's outside of ASCII, so 127. It's a special character, I can't remember which one it is. And this, I think, should have a BOM header. Yeah, let's make it UTF-8. So this has a BOM header. What that means, let's show this. So binary, using my little trick. So you'll see, oh, well, there's a bug to start off with. It's UTF-16 still, I think. Like I said, I'm still working on this encoding stuff. Let's try resaving it. That's probably what it needs. I haven't actually released this code yet. I'll probably release it on Monday now because it needs a bit of testing. There we go. That's better. Just need to resave. Good. So that's not a bug. So what we see here is you see it's just got test, special character test, and at the start you'll see this EF, BB, BF, which obviously is not a character. It's not a character we use. That's called a BOM header. And that just tells anything that's looking at the file, this is in UTF-8. So let's, actually I've got them written down here. So BOM header. So as you can see, UTF-8 is EF, BB, BF. Just a special code, magic code, that we know that's going to be UTF-8. UTF-16 is what we saw just now, FE, FF. And that's the big endian, little endian, obviously just a reverse. So these are the most common BOM headers. There are more, but they get increasingly esoteric and not used so much. These are the ones that are used most frequently. So this BOM header is useful because it tells you what format the file is in. Otherwise, you just don't know. I mean, it could be anything. It could be ASCII, it could be ANSI, it could be UTF-8, it could be UTF-16. You just don't know until you look at the file and try and guess what it is. So a BOM header, in theory, is a good idea because you kind of need to know the encoding a file is in before you open it. But it's never been fully adopted, and it's only an advisory thing. It's not in any standard or anything. Well, they are standardized, but it's not like required. And so most files, like I was showing the one before, this one doesn't have a BOM header. You see, it just starts right at the beginning with no BOM header at all. And it's kind of, if there's no BOM header, then you just have to guess, which is really crazy. You just got to guess what the file is. Now, usually it'll be UTF-8, and it's kind of accepted that if you don't have a BOM header, it probably is UTF-8, but it could also be ANSI, which I haven't talked about yet. I'll get onto in a minute. And it could be ASCII. I mean, you don't even know if it's variable length encoding. So often you just have to look at the file, look at the text, and say, what does this look like? Does it look like it's got 2 bytes for each code point? Maybe it's UTF-16. Now, UTF-16, at least on Windows, you usually put a BOM header on it, at least because that tells you whether it's big endian or little endian. But on things like Unix, as I understand it, they never use BOM headers at all. So it's not going to work on some systems. And the reason I started looking into all this last night, was because someone had a crash because there was a bug in 10x where it was adding a BOM header when it shouldn't have done. And the software they were using didn't support BOM headers and just crashed or didn't work, didn't do what it's supposed to do. Just confused it, I guess. So it's really important to A, not add a BOM header if it wasn't there before, and B, if it has a BOM header, then preserve it. Unless you're changing it, obviously. If you're just overwriting and saving a file, then don't mess with the BOM, is the thing to remember. So that's what I was doing on 10x, and as I said, you can go into the edit and see what encoding it uses and see whether it's got a BOM or not, and change it if you want to, which is really powerful and something usually you don't need to know about because it would just be this, it would just look like this. But occasionally you do need to know about it. So it's good to understand this stuff. Oh yeah, I didn't talk about ANSI yet. Let's put it up here. Now ANSI is something you would never really use in the same world. It shouldn't exist, really, I don't think. It's got nothing to do with ANSI, the American something standards institute, whatever. It's nothing to do with that at all, and it makes no sense calling it ANSI. It's just a name that's stuck, and people have always used it. What it actually means, look at my notes. Where has it gone? There we go. It's actually Windows 1252 code page. Okay, so that's just an encoding, just like Unicode is a character mapping set. This is a character mapping set, and it's kind of specific to Windows. Not really, but that's what it's used on, and it's kind of the default. It used to be the default for Windows. I don't think Windows uses it much for anything now, because it is I'll quickly explain, a really horrible encoding in a way, at least when you mix it with all these other ones. Oh, question. Is there a debugger implemented in 10x? No, there isn't, not yet. Debugger is a big thing to do. I would love to do one day. I'd love to 10x have a debugger, that'd be great. So yeah, it's definitely something I want to do for the future. I mean, at the moment you can do F5 or whatever you map it to and start debugging, and that will actually launch Visual Studio or launch the debugger and start running a program. So at the moment that's the best I've got. I'm going to do a little bit more integration, hopefully, where you can set breakpoints in 10x and then they'll appear in the Visual Studio debugger. So I can integrate it a little bit more, but it would be nice for 10x to have its own debugger. So going back to ANSI, what is ANSI? instead of ASCII using just the first 127, ANSI uses all of it. So ASCII is a subset of ANSI. So you have all the normal characters in ANSI, but then it also uses the top bit. So you have twice as many characters. And those other characters are mapped to other special characters, such as like the different languages like that, which is kind of fine. You could say, oh, it's a compromise. It's better than ASCII, but it's not quite as much or complicated as UTF-8 and UTF-16 because every single character is 1 byte. So it's nice. You get twice as much. It's like ASCII times 2. It's great. The problem with it is that, as I mentioned in UTF-8, that uses the top bit to say how many bytes the next code point uses. So if we've already used the top bit in UTF-8, but ANSI uses the top bit because it's using all characters, then all of the bytes, then how do you know whether it's UTF-8 or ANSI? Especially, as I said, UTF-8 often doesn't have any BOM header. So this could be ASCII, it could be UTF-8, which is pretty much the same thing, like I said, or it could be ANSI. How do we know? If it's got BOM header, you know, but if it doesn't, then you really just have to guess, which is crazy, really. What you have to do is go through and see, is the top bit set on any of it? And if the top bit is set, is it invalid UTF-8? Because UTF-8 is a sparse mapping, so not all character codes are valid UTF-8. So if you see something with the top bit set, it could be UTF-8 or it could be ANSI. So then you check the next character and say, is this a valid UTF-8 code? And if it is, you assume it's UTF-8. If it's not, then you've got to assume it's ANSI. Obviously, that is not foolproof, and it will get it wrong sometimes. And I've seen horrible things happen when files have been saved in ANSI or Windows 1252. So I'd recommend not using that at all. But I support it just because on Windows some things still do still use it. So yeah, that's some of the nastiness of encodings, guessing which encoding it is, ANSI, and all that. I think that probably covers most of it. I'll show you some of the code. Oh, I haven't got it in my Linux workspace. I have to go to Visual Studio. Sorry, using Visual Studio. I shouldn't be doing that. Oh yeah, well, converting, I use STL. I said I didn't use STL in previous talks, but for one or two things I do use it, such as string converting. I mean, the way I'm doing it is not particularly efficient because it's converting it to a STL string and then from an STL string and all that, but it's only done once when the file's loaded or saved. So I've just got convert from UTF-8 and to UTF-8 and UTF-16 as well. I was going to show you text file. No, that one. Should I make this a bit bigger? Can you see? Too big. So yeah, here are the BOM headers. And oh yeah, the swap ending of the thing. So I was just going to explain. It's pretty self-explanatory, but for UTF-16, you've got two types: big endian, little endian. Now on Windows, it's almost always big endian, and if it doesn't say, then you just assume it's big endian. But on other systems, obviously, it could be little endian as well. And like I said, with UTF-16, sorry, you usually have a BOM header, so you know which of these two it is. The BOM header is the same, it's just the opposite way around, obviously. So if you find when BOM headers FEFF, it's big endian. If it's the other way around, it's little endian, then you just swap all of the 2 bytes for every single character. And get it back to big endian, which is what I work with. What was I going to show you in here? Yeah, these functions here. So the first check I do is it ASCII? Because I mean these can be fairly expensive checks because it's got to scan through the whole file, and some files can be multiple meg. So the first thing I do is check the most common case, which is ASCII. So if it is ASCII, then I don't have to worry about UTF-8 or encoding or anything. I just load it straight in. And obviously that's just checking each character's in 0 to 127. It looks like ANSI, that function, is, I'm not going to go through it, but like I was saying, it just checks the top bit. If the top bit is set, then check if it's a valid UTF-8 sequence. And if it finds one that isn't a valid UTF-8, then we assume it's ANSI. God, I'm losing my voice today. And then looks like UTF-16. This is if it doesn't have a bomb, so it checks the bombs first here. If it does, then that's easy, we know what it is. These are the checks for if we don't know what it is. And UTF-16 just checks that it's valid UTF-16, and it checks which way around it is as well, because obviously you have to guess the encoding. So if it has a 0 byte followed by a valid character, then it's big endian. If it has a character followed by a 0 byte, then it's little endian. Again, we're just guessing. It's going to get it wrong some of the time, but that's the best we can do. And it's not just me being lazy. It's just that is the best we can literally do with the way everything's set up. And if we still don't know, we assume it's UTF-8, because it probably is. So that's that. Let's go back to text. Nice text. Let's go to my WString class. So, excuse me. Now, in most editors, they will actually store things in memory in code points, like I said, in 4-byte code points. So whatever the text file is mapped or encoded as, when you load it in, the way to be sure to cover every single character is to use 4 bytes. Now, I don't do that. It may be something I regret, but it's not a huge change if I have to. I actually use wchars. So this is my WString class, which I use for pretty much everything. And as you can see, it uses, God, it's huge, it uses wchars. And as we saw, a wchar uses 2 bytes and it can store 65,000, obviously, characters. Now, for a text editor, that's probably enough. I think I'm going to regret saying this, because I probably should be using 4 bytes. But programmers, even if you're programming using different languages, everyone programs it in pretty much English, but they obviously use different characters as well, especially for European languages and Chinese and Japanese and things like that. People do use obviously different characters, but they usually fall within the 65,000 character set. So a wchar is pretty much good enough for everything. There'll be some characters, weird characters, that it just won't map. But we'll see how that goes. For now, I'm going to keep it as wchars and cross my fingers. I think it's going to be okay, because to be honest, if you're using characters outside of that set, you're probably going to run into problems in compilers and goodness knows what, different things. So unless you're editing web pages that are trying to show Sanskrit or formulas or something, you probably get away with it. Most coders won't ever use anything outside that set. But like I said, if one day I need to change this to a 4-byte code point, then I will. It just means writing all of these functions again, which is a bit of a pain for all the string operations. Because at the moment, it's quite nice because I just use the well, occasionally I write my own algorithms because they're faster, but usually I just use standard C library for everything. I don't use STL or anything like that. Actually, I've written my own algorithms quite a lot. So things, yeah, string copy, WString copy, etc. String comp, things like that. So it was just, I wanted to get something up and running very quickly, so just using these functions I already had them, so it kind of made sense for me. So anyway, we'll see how that goes with 10x. If you ever have a file where a character doesn't show correctly, then do let me know, and I'll think about moving to 4 bytes. But we'll see. So just comment here. The only somewhat reasonable use case of larger code points I can think of is maybe emoji in comments. Yeah, but I'm not sure that we should even be supported really. Yeah, exactly. Emoji should be banned from code, but yeah, there is that. I don't know whether any emojis are included in the wchar set, but probably not. So yeah, see how it goes. Hopefully it'll be okay. Actually, yeah, while I'm on that, I might as well talk about the font rendering. Can I show you code? I don't know if I'm able to find it. I haven't been in here for a while. It's not too big. Hopefully you can still see it. So as I was saying, I mean, a lot of fonts don't support more tan Unicode. Some don't even support Unicode. So some fonts have a very limited character set indeed. You know, even if I could store it in memory, I probably wouldn't be able to display it in many fonts. So what happens is, say you're using Consolas as the default font, and it doesn't have a character for, oh actually, yeah, I wasn't looking at what I was doing, but I'm on the function I wanted to talk about. If it finds a character that's not supported in that font, so Consolas doesn't have, say, some of the Japanese characters, for example, I think, it will actually scan through all fonts on your disk looking for a similar font, so a fixed width font that does have the character it needs, and then it will use that font and insert the character from a different font. It's something other editors do, I've seen, but it's just better to display something, even if it's a slightly different font and maybe looks a bit weird and doesn't quite fit. It's better to at least try and display it as best as possible. So that's what I do if it doesn't have, if the font TTF file doesn't have the character it needs, it just finds one that does and inserts that. So it seems to work, and it seems to work pretty well. So that's that. Right, let me know if you have any more questions. I was going to move on. Well, I was going to talk about string class a little bit more, because it's kind of interesting, maybe, the way I've done it. So my strings are reference counted, which is not that unusual, but string class. So a WString object has a reference to one of these WRefString objects. And that's ref counted. So you know, you can have multiple strings pointing to the same thing, obviously. I don't know how I'm going to represent that in. So if you're just copying around strings by value, then there's very little cost, obviously. But the one interesting thing I did was, I should say this ref string also stores the length as well, because when you're doing lots of string operations, the length is the one thing that, if you have it, it can save an awful lot of CPU cycles. Even just comparing two strings, if they're different length, you don't need to bother comparing them. So I like to have length around in a string rather than calculating it each time. And what I did was, the way I laid this out, because usually you would have this ref string referencing the actual string. So you've got the string class here referencing this object that has a ref count in it, and then usually that would store a pointer to the actual string in memory. But I don't like too many annotations, and so what I did was I combined these two in memory. So the way it's laid out in memory, the ref string is followed immediately by the string in memory. So this is all memory. And it looks like that. And then the W string actually points to my terrible points to that. Instead of pointing to the start of this, it actually points to the string. It doesn't really make a huge amount of difference, but it just makes it nicer to work with, because in the debugger, when you have one of these in a debugger, so it has an AMP value, that is actually pointing to the string, okay, in memory. And if I want to change the reference count or get the length, then I just have to move back ref string size amount of bytes, and then I've got pointed to this class. I can change the ref count or get the length of that string. And I didn't really do it because of cycles of, adding a constant value to register. I mean, that's no big deal, but it's just easier to work with, I find, in the debugger. I rarely need to actually look at one of these in the debugger, but I do always want to be able to see easily MB value in the debugger. And I know I could do that with the NatBiz stuff in Visual Studio Debugger and make it show that, but I just like to be able to have it there. It's easier when you look in the memory window and stuff like that. And instead of doing it this way, where you have two indirections, you only have one indirection on here. So it is a little bit quicker and less touching of memory. Why is MP value of type wchar1 instead of wchar star? I don't actually use this value, and it doesn't need to be there at all, to be honest, because as this comment says, the string just follows in memory. So the string will just be here in memory. So this, it doesn't need to be there, and it could be a char star, like you say. It doesn't really matter, but it's just showing that this is following it in memory. And it's not actually a pointer to it, it is at the actual value, you see what I mean? So, in memory, it will be this, if that makes sense to you. It actually follows this ref string in memory. So here I'm saying, because I don't know what size it's going to be, I'm saying it's size 1, but in reality it can be whatever size it needs to be, because it'll just follow in memory. It's just the way I like to kind of, well, I don't know if it makes it clear, but it makes it clear to me. Yeah. So yeah, it's quite a nice system. The ref counting means I can copy strings and not worry too much. I mean, in reality, because I'm very careful when I ever use strings, I always pass them by reference. I very rarely copy strings anyway. So it's probably not that much of a big saving, to be honest. I think mainly it was just to reduce the fragmenting of memory, to put these two at least in the same memory location. It just means there are fewer allocations, and something like a text editor will have millions of strings, and it's just nice not to have to frag memory all the time and do double indirections and stuff like that. So yeah, I'm quite happy with my little string class. It's done me well for many years, and yeah, and obviously I say it's reference counted, but it is mutable, because if you're holding the only reference and you want to replace, a character with something, then if you've got the only reference, you can just do it there and then. You don't have to allocate a new string. So it's not an immutable string, but it tries to be clever about it and reuse the memory where possible. I think that's all I've got to say about my string class. Other than that, it's fairly standard. Yeah, I've got an empty string label, which everything's mapped to by default. So that I can still incref and decref even empty strings, which is important. So I don't want special case empty strings or anything. So as you can see, constructor says getLength allocates the memory for both those two things combined, allocates that memory, and then just copies the string in. ARCNO actually does the constructor for that WString as well. So that's probably it on WStrings. So let me know if you've got any more questions on that. How are we doing for time? Oh wow, it's an hour already. I'll just briefly talk about what I'm thinking about doing next, which is the syntax highlighting. Now, what I mean by that is I don't mean the parser, I mean the syntax highlighting, and in text they're different. So you can't really see it on this color scheme so well, but you can see members are colored differently. Empty value is a member, so that's colored differently. That's done by the parser. So the parser is the thing that knows about C++ in detail. It knows about your entire code base. It knows about the references, the classes, the namespaces, the members, everything. Well, not everything yet, but as much as I've done so far, it knows about what these things are. So it can do very detailed syntax highlighting. Now, before it does the parser, it does what I call the syntax highlighting. And what that is, it's more of a lexer. So it just knows about keywords and says, oh, this is a size of keyword, that'll be colored, whatever keywords, C++ keywords are assigned to. And that can be just done on a list of keywords basis. So it's in lexer, I think. Yeah, so I've just got lists of various stuff, types, built-in types, common Windows types, library types, keywords, C++ keywords. So it just knows to color those certain colors, and that's very, very simple and very quick. So because parsing, especially when you open a project for the first time, can take, if it's a big project with millions of lines, it can take 30 seconds or something, and you don't really want to be without syntax highlighting for that time. And also, I don't have a parser for other languages yet. I hope to add that over time, but it's going to take a while. So I would like syntax highlighting for other languages. And as you can see, all this is hard-coded at the moment, C++. So what I'm thinking of doing is similar to other editors, I guess, splitting out these keyword lists into a text file somewhere, and then allowing it to be done for different languages. So, and people can add their own languages as well. Also, what I want to do is support regular expressions, so that you can do slightly more complex things, like if it if it's a user keyword followed by a bracket, then we can assume it's a function, things like that. And you can express that in regular expressions. But the reason these have to be quick is, let's see if I can show you. It doesn't have any context, and it literally just does it on the line as it needs it. Lines. Parse lines. Yeah, so this is not the actual C++ parser. The CPP file is literally just a copy of the file, and when in your text editor, when you update lines, it tells CPP file to update its lines, and then it does this quick line parser on it. And the quick line parser, it first tokenizes it, so it says, what is this token? And then it does a little bit of processing, such as am I in a comment block. It also handles strings. I actually added raw multi-line strings recently. And yeah, so strings, simple characters, so for includes and things like that, but it hardly does anything. I mean, this has to run in real time, so it's not something you can do as an async offline process and come back in a few milliseconds. As you type text, this needs to update immediately, tokenize it, and then say this token is this color. So it needs to be very, very quick. So I'm hoping to get, like I said, a simple text file, maybe with regular expressions. It just has a list of rules per language, and you'll get syntax highlighting immediately when you open a file. And then obviously when the parser comes back, slightly later on, for C++ at least, it'll give you more detailed syntax highlighting, such as members and classes and namespaces and stuff like that. So that's my goal. I haven't really given it a lot of thoughts yet, exactly the format I'm going to use. It'll probably be a simple text format. As you can see, like my settings file, I'm a big fan of really, really simple text formats. Occasionally I use XML, but if people are editing it, it's just nicer to be simple, I think. So it'll probably be a simple text file. But yeah, let me know if you have any ideas or preferences on that. I'm still, like I said, I'm still thinking about it and how I'm going to actually do it. But yeah, that's as far as my thinking's gone so far. I said I was going to start working on that this week, but I never got to it because I had a few bugs to fix, things like encoding and stuff like that. But that's done now. So I'm hoping to get to it next week. Excuse me. Right, as I seem to be losing my voice today, I think I better leave it there. Unless you have any more questions, anyone? Oh yeah, I was going to say, if you are interested in more details on the encoding stuff, I wrote a blog on my website a little while back. Text encoding, wow, 2017. I've been working on 10x at least 3 years. And this goes through into more detail on what I was talking about earlier. In a very simple way, just tells you what all the encodings are, how they work. And yeah, so if you're interested, please go there. And show you. That took a long time to come up. That's not the 10x way. I have to look into that. But yes, if you do like 10x and you think it's a good thing, please think of supporting it. And you get access to the Discord channel where you get priority support. So I'll try and get bugs fixed as fast as possible for anyone in there. You get the discard for any of the tiers. It doesn't matter which one you do. So thank you very much for the people that do support. I really appreciate it, and it's great to have all your feedback in the chat every day. It really makes me want to get up and fix those bugs for you. So yeah, I hope you enjoyed it. And I should be doing another one next week on Saturday, so I'm trying to make it a regular thing. Do let me know if there's anything you would like me to go into more detail on. This week I was originally planning to go into detail into my core classes, so maybe I can do that next time. So my arrays and hash maps and things like that, show why 10x is as fast as it is. But yeah, like I said, if you want me to talk about anything in particular, then do please let me know. So thank you for watching, and happy coding. So I'll see you next week, hopefully. Okay.